are watching Cam Science.
In this video, we'll be solving question paper 4-2, that is subjective paper of 0620 chemistry of the examination series October-November 2022. And we'll be solving first few questions, almost half the paper in this video, and the remaining paper will be solving in the next video. So here is our first question, where it says the diamond and graphite are different solid forms of carbon. The carbon atoms in diamond and graphite are arranged in different ways. State the number of covalent bonds each carbon atom has in diamond. Now we know that the carbon atom is covalently bonded to each other in the diamond in a tetrahedral structure. So there are 4 covalent bonds with each carbon atom in the diamond. Let's go ahead with the next question. Says the state the term used to describe the structure of diamond. Now it's already mentioned that the bonding in diamond is covalent bond, so the structure is a giant covalent structure. Giant covalent structure. You can also call it as a macromolecular structure of diamond. Next question says name an oxide that has a similar structure to diamond. So the substance which has the similar structure to diamond is silicon 4 oxide, or you can also call it as silica, or we can also call it as silicon dioxide. Anything is acceptable. Next question says describe the arrangement of atoms in graphite. Now in graphite, the carbon atoms are covalently bonded to 3 other carbon atoms. As we know that the graphite is also purely made of carbon, so it's covalently bonded to 3 other carbon atoms in a hexagonal ring structure, and these rings are found in layers. So we can write that in the hexagonal ring structures and has layers of the ring structure. So this is how it carries 2 marks. 2 marks is for describing the hexagonal ring structure where carbon are bonded to 3 other carbon atom in covalent bonding, and also it has layers. These 2 sentences will carry 2 marks. Now let's go ahead with the next sub question. Explain how graphite conducts electricity. Now graphite conducts electricity due to mobile electrons, or you can also call it as delocalized electrons. Both of it is acceptable. It's just 1 mark, so you can write it in your own language. Your question F says Buckminster fullerene is a simple molecular form of carbon. The relative molecular mass of Buckminster fullerene is 720. Determine the number of carbon atoms in 1 molecule of Buckminster fullerene. Here it says it has a simple molecular structure made of only carbon. Now it also says the relative molecular mass is 720. So what we need to find is divide 720 by 12. Why? Because now if the total mass is 720 and the mass of 1 carbon is 12, so 720 divided by 12 to find the number of carbon atoms. And so the answer is 60 carbon atoms. 60 carbon atoms are present in the Buckminster fullerene structure. All form of carbon, next question, all forms of carbon burns to produce carbon dioxide. Name the substance used to test for carbon dioxide. Now we know that the substance used to test the carbon dioxide is lime water, because on passing carbon dioxide, lime water turns milky. Let's see the next question 2. Next question 2 is sodium is a reactive metal. Suggest why sodium is stored under oil. Now sodium, as we have already written, it's a reactive metal, so it should not come in contact with water or air. So we can say that sodium is prevented to prevent its contact with water and air, because if it comes in contact with air and water, it's going to react. If especially with water, it will react explosively. So this is how we need to prevent it with water and air, and that's why we keep it under oil. Okay, next sub question says sodium burns in air to form sodium oxide Na2O, and this is the formula. State the term given to a reaction in which a substance burns. Now burning reaction is simple combustion. Combustion reaction is the burning reaction. State the color of the flame seen when sodium burns. Now we know that when sodium burns, the color of the flame is yellow. If you don't know, you need to remember that yellow color is the flame produced when sodium burns. Write a chemical equation for the reaction which takes place when sodium burns in air to form sodium oxide, and the formula is already given here, sodium oxide Na2O. So let's make a chemical reaction, and obviously when we are writing a chemical reaction, by default it has to be a balanced chemical reaction. Now if you make it balanced, we need to add 2 in front of sodium oxide to make oxygen balanced on both sides, and that's why sodium has 4 as a coefficient added to again make the sodium balanced, because here on the product side the sodium has changed to 4. So this is how a balanced chemical equation is written. Let's go ahead with the next sub question. Which says that complete dot and cross diagram to show the electron arrangement and charges of the ions in sodium oxide. Now sodium oxide, we can see that one of the shell of sodium is given for oxygen and sodium, again one shell for each is given. Now we know that the charge of sodium is +1, so I'm writing +1 on both sides, and the charge of sodium is -2. That's what I have written. Now I need to add the electronic structure, that is shells I need to add with the electrons. Now we know that the sodium has a structure of 2, 8 and 1, out of which the 1 electron is lost out, so we are left with the second shell with 8 electrons. So let's add second shell to both the sodium atoms. Okay, so here I am adding another shell to the sodium, and here is 1 shell given. Let me add 1 more shell to the next sodium. And as we can see that the sodium electrons are represented by crosses, so I am also adding crosses for the sodium electrons. And as we have already discussed, the second shell should contain 8 electrons, so I have added 8 electrons in the first sodium. Let me add next 8 electrons in the next sodium. Now let's go ahead with the oxygen atom. Let me add a shell to the oxygen atoms also. So here is the oxygen atom shell. Let me add electrons. Now in the oxygen atom, the electrons are presented with the dot, but the oxygen have 6 electrons in its outer shell, because the electronic structure of oxygen is 2 and 6. So it has 6 electrons of its own in the outer shell, but 2 more electrons from the sodium has been added, so that I have to present in the form of cross. That is 1 electron from each sodium. You can see that the 1 electron from each sodium will go. So here is how I'm going to draw the dot and cross diagram of the electron arrangement of sodium and oxygen. I have removed the arrows which I have drawn, because that was not what we are supposed to draw, because that was just for the explanation. So let's go ahead with the next question. Here it says sodium reacts vigorously with water to form aqueous sodium hydroxide, which is a strong base. Explain in terms of proton transfer what is meant by a base. Now we know that base is an acceptor of protons. So base is an acceptor of proton because the one which donates proton is an acid and the one which accepts proton is a base. The next sub question says state a pH number that indicates the presence of a strong alkali. Generally 13 to 14 is a pH that is for a strong alkali, but here I am writing 14 because we are talking about sodium hydroxide, which is extremely strong alkali. Now state the color of methyl orange in aqueous sodium hydroxide. Now we know that methyl orange is red in acid and yellow in base. So with base sodium hydroxide, methyl orange is going to show yellow color. Now let's go ahead with one more next sub question where it's written that the equation for the reaction is shown. Now the equation of sodium with water is shown here, releasing hydrogen gas, and it's a moles question, that is quantitative analysis question. It says calculate the concentration of sodium hydroxide formed in grams per dm cube when 0.345 gram of sodium is added to 50 centimeter cube of distilled water. Assume there is no change in the volume. Use the following steps. Now calculate the number of moles of sodium added. Now how much of sodium have we added? That is 0.345 gram. Now if it's written in gram, that is mass, and we are supposed to calculate the moles. So the formula which we are going to apply is N is equal to M upon MR. So mass is 0.345 gram and the mass, molecular mass of sodium is 23. We know that, but you can always refer periodic table which is given at the end of this question paper, and the answer is 0.015. So I'll write it here in the dash, that is 0.015 mole. Now I always prefer that if we have written answer here in the blank space, shown the calculation, still we need to write the correct answer in the dash given, and don't forget showing your calculation, that is the working has to be shown to get full marks. I'll always prefer that. Now determine the number of moles of NaOH formed. Now NaOH formed, let's look at the equation. How does it work out? If we look at the equation, it says that the 2 moles of sodium is required to form 2 moles of sodium hydroxide. So in that case I would say that the number of moles formed of sodium hydroxide is same as sodium. So I'll just write in the bracket here that the moles of sodium is equal to the moles of sodium hydroxide, and that is 0.015 moles. So I'll be writing that on the dash again. Now the next step is calculate the concentration of sodium hydroxide in moles per dm cube. Presently we are supposed to calculate moles per dm cube concentration only, and the formula is concentration is equal to moles divided by volume, where our moles is 0.015, and we can see that the volume given here is 50 centimeter cube. So let me write 50 centimeter cube down here, but according to the formula volume always has to be in dm cube, so I'm dividing it in by the 1000. So if I'm dividing 50 by 1000, the 1000 will go in the numerator, and that's why my answer will change to 0.3 moles per dm cube. So 0.3 moles per dm cube. Now let me clarify one more point here, that we are supposed to write actually the answer to 3 significant figures, so we can add zeros after the our moles, that is 0.015 also, and in our answer also I should add 2 more zeros to make our answer in 3 decimal places or 3 significant figures, but here I think the answer will be acceptable even if you don't write, but then fine, let's be on the safer side and write it. Next step is determine the MR of NaOH and calculate the concentration of NaOH in grams per dm cube. Now our answer is in moles and we want it in grams per dm cube, that is we are going to change the moles into mass. Now if we want to change moles into mass, then the formula is moles into MR and we get the mass. So what are we going to do is calculate the MR of NaOH. That's what they have written first. The MR of NaOH calculated should be 40, but let me show you the calculation here because sodium carries the atomic mass of 23, plus oxygen is 16 and plus hydrogen is 1, that ends up with 40. So the MR of sodium hydroxide is 40, and then we need to multiply the moles per dm cube answer into the MR of the NaOH, and so our answer is 40 multiply by the moles which we had, moles concentration which we have calculated in our first step, that is 0.3. So our answer to this should be 12 grams per dm cube. It was 0.3 moles per dm cube. Now if we change it into grams per dm cube, then it is 12 grams per dm cube. So this is our final answer. Now let's go ahead with D sub question, where it says when NaOH is added to iron 3 chloride, a solid product is formed. Name the type of reaction where a solid is formed from two solutions. Now if we are mixing two solutions and we get some solid product, then the reaction is a precipitation reaction. Precipitation reaction, that is the answer. Now state the color of this solid product. Now let's have a look at the question first, where we are adding NaOH to iron 3 chloride. Now iron 3, that is Fe3 plus, reacting with sodium hydroxide produces the red brown precipitates. So the color of the precipitates or the solid should be red brown. Name this solid product. Now if iron 3 oxide is reacting with sodium hydroxide, the product formed is iron 3 oxide. So I will write Fe3 oxide or name. So name is written, so I'll have to write it in words only. So it's iron 3 hydroxide. Iron 3 hydroxide is formed because it reacts with sodium hydroxide. So this is how you form a precipitates of red brown of iron 3 oxide. Now write the ionic equation for the reaction, include the state symbols. Now as we have already know that iron 3 oxide is formed, so the formula for iron 3 oxide is FeOH thrice, and we know that they are the precipitates, so the state symbol for Fe3 oxide, that is iron 3 oxide, should be solid. So I am writing S in the bracket. Now that is formed from iron, so we need to write iron in the ionic form, that is Fe3 plus, and we know that we have taken the solution, so we'll write aqueous. Sodium hydroxide is reacting where hydroxide forms a precipitate, so again we have to write OH minus and in the aqueous form. Now what I suggest is, if you are still confused that what should be written on the left hand side, on the reactant side, then that's why, see, I've written the product first. Now if we have written the product first, FeOH thrice, then only write the ions of these product on the left hand side. So what was the ion? Fe3 plus is the ion, so that's what I've written. OH is the another ion, so OH minus ions I have written on the next side, that is left hand side, and both of them were in aqueous form, so we have added the state symbol of aqueous. That's it. So if you are confused, write the product first and then split it into its ions and write it on the left side. That's how I'll make it simple. Let's go ahead with question 3, where it says sulfuric acid is manufactured by an industrial process. Sulfur is obtained from sulfur containing metal ores. Now, sulfur containing metal ores. The sulfur is a metal ore converted to sulfur dioxide, which is then oxidized to sulfur trioxide as shown here. So this is the reaction for the formation of sulfur trioxide from sulfur dioxide. Now the question here, it says that name a metal ore which contains sulfur. So the most common ore which we have studied in our syllabus is zinc blende. Zinc blende is the ore which contains the sulfur, that is ZnS. Now describe the process which converts metal ores to sulfur dioxide. Now metal ores to sulfur dioxide, so that shows that if ZnS is the ore and we need to convert this into sulfur dioxide, that means it's an oxidation process. So what we'll do, describe the process it is written. So we need to write it in full sentence. We can't write it in just word, that is oxidation. So what we'll call it as heating or roasting it in air. Heating or roasting. Roasting is also one of the same thing as heating in presence of air. Enough air actually should be written, but that's not required here because it's just written describe the process. So heating in air, heating in presence of air, that's the answer. Next sub question, name the industrial process used to manufacture sulfuric acid. Now that is contact process. Contact process is the answer for producing sulfuric acid, the most common process for producing sulfuric acid. Next sub question D here says the reaction that produces sulfur trioxide is an equilibrium reaction. The forward reaction is exothermic. State the temperature used to make sulfuric acid. Now the temperature used here is 450 degrees Celsius. Unit degree Celsius is already written, so I'm just writing 450 degrees Celsius. But actually it's allowed that you can write from 350 to 500, but most of the process we mention and specify 450, so I'm also specifying here. The pressure used is 1 to 2 atmospheric pressure. So even you can write 1 atmospheric pressure, or you can even write 2 atmospheric pressure. I'm just writing the intermediate, that is both. Next sub question says name the catalyst used. The catalyst used is vanadium 5 oxide. Vanadium 5 oxide. I think it's a written name, so I'm writing it full, but if you are supposed to write it in formula, you can write V2O5, but here formula is not allowed as it's written name. So name fully, mentioning the oxidation number also, because that's important. Now describe the two features of an equilibrium reaction. For any equilibrium reaction, the two important feature is that the rate of forward reaction, is equal to the rate of backward reaction, That is very important. This is the most important feature of the equilibrium reaction, so I'm writing it here. And the second feature is that the concentration of both reactants and products, should remain constant. So concentration of reactants and products are constant at equilibrium. That are the two main features required for an equilibrium. Even if they are asking the definitions of equilibrium, you are supposed to write these 2 points only. It's a question says state the effect, if any, on the position of equilibrium when the following changes are made, and explain your answer. So first you are supposed to state the change and then explain it. if the temperature is increased. Now it was written that the forward reaction is exothermic in the question above. You can always pause, reverse and reread the question. I remember the question, it says the forward reaction is exothermic. So according to Le Chatelier's principle, to oppose the change, it should favor the backward reaction. So first, if we state the effect, then I'll say that equilibrium favors the backward reaction, or you can say reverse reaction also favors backward reaction. You can also write favors the left hand side reaction, backward reaction favors the reactants, anything can be written. Now the reason we are supposed to explain is that because forward reaction is exothermic, so to oppose the change, the equilibrium will favor the backward reaction, that is endothermic side. Now if the pressure is increased, now to look at the effect of pressure, let's have a look at the reaction again. Now here you can see that there are 2 moles of sulfur dioxide and 1 mole of oxygen, so total up with the 3 moles of both the reactants, and on the product sides we have just the 2 moles of sulfur trioxide. So where are less number of molecules? On the product side we have fewer number of molecules, and the question says that if the pressure is increased, so if the pressure is increased, what's going to affect is that the equilibrium is going to favor the forward reaction, that is the product side. So you can write it favors the product side, it favors the right hand side, you can write anything, and we need to specify the reason. The reason is that there are fewer molecules on the product side, because fewer molecules present on product side, fewer molecules present on the product side, because increase in the pressure will affect the side with the fewer molecules. That's how it's actually working. Increasing the pressure always favors the side with fewer number of molecules, and here if we have fewer molecules on the product side, so it's favoring the product side. Now the next sub question says, explain in terms of particles what happens to the rate of reaction when the temperature is increased. Now we know that the rate of reaction increases on increasing the temperature, that is fixed. Now if we explain in the particle size, in terms of the energy of the particles, in terms of particles, not the size, in terms of particles, if we explain, then we can say that increase in the temperature, the particles gain energy, or the particles have more energy, And so what happens is that the number of particles, hence number of particles having the activation energy, that increases. So number of particles having energy more than the activation energy, having energy more than activation energy increases. So number of particles having more energy increases. So that's how we are going to mention in the particle theory, that the number of particles having energy more than activation energy increases, and because of that what happens? Hence successful collision I'll write. Number of collision also you can write, but I am specifying number of successful collisions. Why successful collisions? Because all the collisions doesn't end up in the reaction. So the collisions which end up in the reaction are called successful collisions. And we also need to mention per unit time increases. Per unit time increases. That's we need to mention about the time. Or you can also write that the frequency of the successful collision increases, that is also allowed. So let's read again. Rate of reaction increases because particles have more energy, hence number of particles having energy more than activation energy increases, and hence the number of successful collisions per unit time increases, and this is how the rate of reaction increases. So this carries 3 marks because we have stated the reason, and then we also have mentioned the reason for it in terms of particles and its energy. Next sub question says, name the compound formed when sulfuric acid reacts with ammonia. When ammonia reacts with sulfuric acid, ammonium sulfate is produced. So the name should be written in again words. So I'm writing it in words. Ammonium sulfate is the name of the compound when sulfuric acid reacts with ammonia. Now ammonia is a base, sulfuric acid is an acid, so it's going to form the salt ammonium sulfate. So I'm here ending the first video. In the next videos we will one more video will be solving the remaining questions of this paper.